Today we are going to discuss about solid state. First of all, we will know the definition of solids. In solids, constituent particles are held very close to each other, meaning in container, if we take a solid's constituent particles are arranged very closely and tightly like this. Coming to the general characteristic features of solids. In general characteristic features of solids, first point is solids have definite mass, shape and volume. Coming to the second point, they have a strong intermolecular force of attraction. Intermolecular force of attractions are very strong. Coming to the next point, interatomic distance is very short, and next point is they are generally incompressible, meaning they cannot be compressed, and rigid in nature, meaning hard, and they cannot be compressed and they are hard in nature. Coming to the classification of solids. Solids are classified into two types. One is based on the arrangement of constituent particles, and another one is based on the intermolecular forces of attraction. We'll see one on the basis of order of arrangement of constituent particles. And in this first classification, solids are classified into two types. One is crystalline solids, another one is amorphous solids. We'll see the difference between the crystalline solids as well as amorphous solids. Let us have a screenshot of this. Just to take a screenshot of this. Coming to the Difference between the crystalline solids and amorphous solids. We'll take crystalline solids. And amorphous solids. And we'll have properties also. Property. First property of crystalline solids and amorphous solids is, first property is based on structure. In crystalline solids, there is an definite geometry, meaning definite shape, definite geometrical shape, whereas in amorphous solids they do not have any definite geometrical shape. Coming to the second property is melting point. Crystalline solids have sharp melting point, whereas amorphous solids do not have sharp melting point. Coming to the third property is nature. Crystalline solids are also called as true solids, whereas amorphous solids are also called as pseudo solids or supercooled liquids. Why do they are called supercooled liquids? The reason is they have tendency to flow. They have a tendency to flow. Hence, they are also called as supercooled liquids. For example, if you take out a glass, generally a glass panes which are fixed to the windows or the doors of old buildings, they are found to be slightly thicker at the bottom than at the top. This is the example of amorphous solids. If you observe very carefully, for an old buildings or windows of old buildings, glass panes are fixed to the windows such that they are found to be slightly thicker at the bottom than at the top. Coming to the next property is cleavage property. Cleavage property. In crystalline solids, when we cut the crystalline solids with a sharp-edged tool, they split into two pieces or two halves, where the two halves which are generally generated have surfaces very smooth and plain. Meaning of this is, in crystalline solids, when they are cut, there is an regular cleavage, whereas in amorphous solids you don't find any such sort or such type of regular cleavage. We'll observe irregular cleavage. Once again I will repeat this cleavage property. In crystalline solids, when we cut with a sharp edged tool, these crystalline solids, when we cut with a sharp edged tool, they split into two halves, and those two halves which are generated newly have a surface or possess a surface which are smooth in nature. Whereas when we cut the amorphous solids with sharp edged tools, they cut into two pieces such that they do not have an regular shapes or regular surfaces, meaning they have an irregular surfaces or irregular cleavage. They undergo irregular cleavage. Coming to the next property is order of arrangement of particles. In crystalline solids, they have long range order, meaning constituent particles are arranged in a long range, like in a very long range like this, very long range. Whereas in the amorphous solids you can only observe up to a short range order, only up to short range. And then this will be in a disordered manner. Only you can observe only a very short range. Coming to the next property is heat of fusion. What is heat of fusion? Heat of fusion is nothing but it is an amount of heat required to melt 1 mole of solid. This is nothing but heat of fusion. Heat of fusion is nothing but amount of heat required to melt 1 mole of solid is called heat of fusion. In crystalline solids, we observe definite heat of fusion, whereas in amorphous solids we do not observe, they do not have a definite heat of fusion. They do not have definite heat of fusion. Coming to the last property is anisotropy and isotropy. Meaning of anisotropy and anisotropy: in crystallines we observe the nature of crystalline solids is anisotropic in nature, whereas in amorphous we observe a nature called isotropy nature. What is this isotropy nature and anisotropy nature? Just have a screenshot of this amorphous and crystalline solids, difference between amorphous and crystalline solids. These are the differences between the crystalline and amorphous solids, and there are 7 points regarding the crystalline and amorphous solids. Let us know what is isotropy and anisotropy nature. Just have a screenshot of it. Coming to the anisotropy, anisotropic nature. Anisotropic nature, it is nothing but the physical properties uh, such as what can I say, a refractive index, comma, electrical resistance, etc., shows different values in different directions, in different directions. What is a anisotropic nature is the physical properties such as refractive index and uh, electrical resistance, etc., shows different values in different directions, and this is due to the reason and this is due to the reason that different arrangement of particles in different directions. We are able to understand what is anisotropic nature. Anisotropic nature is nothing but the physical properties such as refractive index as well as electrical resistance, etc., shows different values in different directions, and this is due to the reason that uh, due to the different arrangement of particles in the different directions. Coming to the isotropic nature. Isotropic nature is the same, but as in the place of different, we use same values in any direction. Same values in any directions. So we'll write on it the physical properties. The physical properties such as refractive index and electrical resistance, etc., shows same values in any direction. This is due to the reason. A reason is due to irregular arrangement of particles in all directions. See, we'll try to understand this anisotropic and isotropic in a simple manner. Let us draw a simple two-dimensional arrangement of two different kinds of atoms, and if we arrange them like this, let us see different kind of arrangements. I will draw in two-dimensional different kinds of atoms. Let us see. This is one kind of atoms, and another kind of atoms I am arranging like this in a two-dimensional manner. This is nothing but an two-dimensional arrangement of different kinds of atoms. This is one kind of atoms, and these are the another kind of atoms that we have arranged. And when a physical property is measured along one line, let us draw one line, and the line will be like this. And let us say this line is CD, and another line, if we pass like this, let us consider this line, and this is A, and this is B. And if you observe both the lines, in CD it contains alternate types of atoms. See, this is alternate type of atoms, while as AB line contains only one type of atoms. This is one type of atom, one type of atom, one type of atom in one line. This is nothing but anisotropic nature, isotropic nature, where the physical properties shows different values in different direction, and physical properties shows same values in any directions. This is due to, I told you, different arrangements of particles in all directions, and the another one is different arrangement of particles in different directions. This is nothing, this is all about anisotropic nature and isotropic nature.